Hello. Today we're going to be talking about determining whether or not lines are parallel or perpendicular or possibly neither. In order to do that, you probably might remember some of this from Algebra 1, but we have things now more formalized with theorems. There are a couple of theorems we need to talk about. So the first theorem is 3.13, which is slopes of parallel lines. Putting this in a little bit less mathy language, when you have lines made in the coordinate plane, xy coordinate plane like you're used to, any two different lines from each other that are not vertical are parallel if and only if they have the same slope. So if we use our slope formula to find m of the first line or the slope of the first line will be the same as m of the second line. Also, if you had two vertical lines, they would be parallel to each other. So in order to be parallel, we have to have the same slope. Next up is perpendicular. Same idea, we're talking about two lines in the xy coordinate plane. If you have two non-vertical lines, they are perpendicular, meaning they intersect at right angles, like we've talked about before, if and only if the product of their slopes is -1. So as you can see here, when you multiply the two slopes together, you get the first slope times the second slope equals -1 exactly. If you get anything else other than -1, they're not perpendicular. Because vertical lines are undefined, they do have to make this point here. Vertical lines have an undefined slope. If you have a horizontal line, it'll be perpendicular to a vertical line. You can actually see that with the x and y axis there. X axis is the horizontal line. It is perpendicular to the vertical line that the y axis is. Another way of saying the product of their slopes is -1 is something you might have learned about in Algebra 1. Perpendicular lines have slopes that are opposite reciprocals. When you take an opposite reciprocal of a number, you change the sign, so either positive to negative or the other way around, and you flip the fraction over. So in our example here, 2/3, the opposite reciprocal of that is -3/2. If you multiply 2/3 times -3/2, you get -1. So two different ways of saying the same thing. Most of what we'll be looking at today is looking at some lines and saying if they are parallel or if they are perpendicular. And so the way we do that is by going back to our slope formula, which I'm going to write up here just so we can see it in front of us. y2 minus y1 over x2 minus x1. So looking at this example here, we have lines A, B, C, and D. We need to, in order to figure out which lines are parallel and which lines are perpendicular, don't trust your eyes. We need to find the slope of each one. So let's start with line A. The slope of line A is y2 minus y1, x2 minus x1. I'm going to use the first point I see here as x1 and y1, and then this one will be x2 and y2. Doesn't matter as long as you're consistent. So I'm going to call 2y2 minus y1, 3, over, I'm going to call -3x2, -3 minus 0. When I do that, 2 minus 3 is -1. -3 minus 0 is -3. I can reduce that fraction. -1 over -3 is +1/3. I'm going to quickly show you that you can do that in Desmos also. So remember to hit your fraction, or to get a fraction, hit the division sign first. Then type in each part of your fraction. And it gives you a decimal, which isn't very convenient for a slope because we usually think about that as a fraction. If I click on this little, it looks kind of like a fraction here, box over box, that'll turn it into a fraction. So you can check your work or do your work in Desmos this way. Okay, so 1/3 is the slope of A. Now let's find the slope of B. So I'm going to use 0, -1 as my second point, 2, 0 is my first point. So when I plug things in, y2 is -1 minus y1 is 0. x2 is 0 minus x1 is 2. When I simplify, -1 minus 0 is -1. 0 minus 2 is -2. Negative over negative is the same as a positive. I could have typed this into Desmos and done that little fraction trick and gotten the same answer. Line C, same idea. I'm going to treat -1, -5 as my second point. So -5 is y2 minus -4 for y1. -1 is x2 minus 1 for x1. -5 minus -4 is like -5 plus 4, so -1. -1 minus 1 is -2. Negative over negative is the same thing as a positive. You probably already know something by now, but let's find one more slope before we say any answers. So now we got to deal with the last line, which is line D. And it really doesn't matter which order you found these in, by the way. I just kind of went alphabetical. I am going to treat -2, 0 as the second point. See how -3, 2 is also on line D? I'm going to count that as the first point. So y2 is 0 minus y1 is 2. x2 is -2 minus x1 is -3. Simplifying that out, 0 minus 2 is -2. -2 minus -3 is the same as -2 plus 3, which is 1. And we can either write that as -2 over 1 or -2. So they want to know which lines are parallel and which lines are perpendicular. So parallel have to have the same slope. Which two lines in this have the same slope? Line B and line C have the same slope. So we can say that line B is parallel to line C. Perpendicular means that the slopes have to be opposite reciprocals, or you can think of the slopes as when you multiply them together, you get -1. So notice that 1 over 2 and -2 over 1 are opposite reciprocals. So B is perpendicular to D. I'm using the symbols here, good thing to get used to. And also, since C had the same slope as B, then C is perpendicular to D. You can confirm that when you multiply those fractions, you do get -1 in Desmos. 1 over 2 times -2, or -2 over 1, no matter how you write it, will give you -1. Last bit here, they didn't give us a picture, but for these problems, we're going to say if the two lines are parallel, perpendicular, or neither. We're going to do these things the exact same way as we did before using the slope formula. So I'm going to start with line 1. My second point is 5, 5. So y2 is 5 minus y1 is -7. x2 is 5 minus x1 is -5. Let's, just because we haven't done this much yet, let's do that in Desmos. So hit your division sign first. 5 minus -7 over 5 minus -5. It gives us a decimal. We'd rather have a fraction. So hit the fraction button. We get 6 over 5. Now let's find our other slope using line 2. My second point is 6, -2, so y2 is -2, minus y1 is 8, x2 is 6, minus x1 is -6. Let's try that in Desmos. So again, fraction, division sign to get your fraction. -2 minus 8 over 6 minus -6. We get a crazy fraction, or crazy decimal. Switch that to a fraction. I get -5 over 6. What do we notice about these two fractions? Well, you might notice right away that it's the same numbers involved, but one is flipped over from the other. One is positive, one is negative. These are opposite reciprocals. So if we think about it that way, we can say they are perpendicular. If that didn't immediately jump out at you, the other way you can check to see that they're perpendicular is you can multiply the two slopes together. 6 divided by 5 times -5 divided by 6 gives me exactly -1. So those two are perpendicular. Let's try the next one. I'm not going to write the slope formula out every time because we've seen it a lot of times now. I'm just going to start with plugging in y2 and y1 and everything else. My second point is 10, 1, so y2 is 1 minus 0 for y1. x2 is 10 minus x1 is 5. And that one would probably be pretty easy to do in your head, but let's do Desmos for practice. Division sign, 1 minus 0 over 10 minus 5 gives me 0.2, but we like decimals better for these. Let's change that into a fraction, and we get 1 over 5. Same thing for the second line. y2 is 1 minus y1 is 0 over x2 is negative 5 minus x1 is negative 10. Let's try that in Desmos. Division sign. 1 minus 0 over negative 5 minus negative 10 gives me 0.2, but let's switch that to a fraction. I also get 1 over 5. What do we notice about our two slopes? Our two slopes are the exact same number. When your slopes are the exact same number, they are parallel. Let's do one last one. So I'm just going to jump in with my slope formula. y2 is negative 4 minus y1 is negative 1. x2 is negative 8 minus x1 is 4. Let's use Desmos to help us out. So division sign. Negative 4 minus negative 1 over negative 8 minus 4 gives me a decimal. Let's switch that to a fraction. I get 1 over 4. Now let's try the other one. y2 is 5 minus y1 is negative 10. x2 is 4 minus x1 is negative 2. Let's use Desmos just because we can. Division sign, 5 minus negative 10 over 4 minus negative 2 is 2.5. But let's switch that to a fraction. I get 5 over 2. So what happens here? The slopes are not the same, so they're not parallel. The slopes are not opposite reciprocal, so they're not perpendicular. So this one is neither. Most lines, two sets of lines, are going to be neither. But today, mostly we're focusing on lines that are parallel, which are the same slope, or perpendicular, which have slopes that are opposite reciprocals. That is it for today. Have a fantastic day.